Hello everyone, I'm Sachith from the Augmented Human Lab at the University of Auckland, New Zealand. So here I am excited to present the ClothTiles at CHI 2021. Well, it's quite interesting that humans have evolved to a point where they can't live without wearing clothes from birth anymore. So at present, a vast number of research is focused on smart clothing, especially focused on diverse sensing mechanisms. However, the actuation dimension of clothing has been ignored most of the time. In this work, we present ClothTiles, a prototyping platform to fabricate customized actuators on clothing using 3D printing and shape memory alloys. Our main contribution is providing an easily customizable and versatile fabrication technique for enabling actuation on textile interfaces. Here, we have used commonly available raw materials such as flexible 3D printing filaments, SMA wires, and of course, a piece of clothing. This technique basically involves two steps. First, we have to print 3D structural elements onto the piece of clothing. Secondly, we integrated an SMA wire into the 3D printed substrate. Here, we demonstrate the concept of clothing actuation using a fundamental ClothTiles element. Because we have the advantage of having a variable stiffness, we can easily control the thickness of the 3D printed substrates. So in return, this allows us to regulate the actuator's behavior. We propose 5 ways to combine the ClothTiles basic elements to realize different deformation types over an extended area. They are linear, perpendicular, curved, circular, and angular methods. And each aggregation method has its own unique actuation behavior, as you can see here. Also, we can control the deformation forces by varying the basic element scaling properties. For example, by using widthwise scaling, we can render a more distributed force over a larger area of clothing. In the same way, using the lengthwise scaling technique, one can achieve a stronger deformation force that can increase the bending angle. As shown here, you can see how the bending angle of the basic element increases with the anchor point length. Also, with different levels of rigidity in the clothing, we can also control diverse actuation levels in terms of displacement. When it comes to the directionality aspects, we propose 2 placements where the cloth actuator can be placed. Those are outside and inside of the clothing. In each placement, we identify 3 directions along which the cloth actuator can be oriented. Based on each arrangement, several properties of the cloth actuation can be determined, such as the bending direction, visibility to the outside, and the type of sensation. We can achieve a unique set of actuation mechanisms by combining primitive structures that I mentioned before. Figure A on the top left incorporates a linear aggregation mechanism together with a variable scaling mechanism in a longitudinal direction. This generates a more intense pulling effect from a specific point on the cloth. Also, if you look at figure B, this actuator allows clothing surface to deform as a spherical cap. To observe how users find the ClothTiles, we performed a co-design study with the support of an expert. At first, we interpreted that the users would only design functional clothing, but instead, they were mostly concerned about the aesthetic aspects of the clothing. These are some cool ideas that users came up with. The first one is a face mask loosener. He had an issue with his face mask generating vapor on his spectacles when breathing. Another participant wanted to integrate a wrist compressor in his workout gloves to receive subtle notifications while doing exercises. When it comes to aesthetic designs, users came up with awesome ideas. One of the participants wanted to print a dog on his t-shirt that can visually stay. Also, another participant wanted to integrate a slight massager on her eye mask. And mainly, she wanted to retain the aesthetic aspects of that. From the user feedback, we could confirm that ClothTiles potentially can fulfill both functional as well as aesthetic aspects of clothing up to user expectations. Also, we developed a set of clothing actuators to further demonstrate the potential of ClothTiles for functional and aesthetic clothing applications. And here's my amazing team behind this project. We are looking forward to future collaborations related to this project and other projects. And you can also check out our websites for more details. So feel free to contact us for further discussions. And this is a wrap, and I hope you guys enjoyed it. Thank you.